Okay, so question number 3. The total area under a normal distribution curve must equal, I think this is one, but I don't know 100%.
Is it 1?
I think it is.
Okay. I really wish that the quizzes in this class were like the quizzes in chemistry, where the questions are like on a separate page.
What do you mean?
Were your quizzes in chemistry like that? Like every question you have to hit next to get to it, so you're not like.
Oh, yes.
Yeah. I feel like this class needs to be that way too.
I can see that, yeah.
So under
under certain circumstances, a normal distribution curve can drop below the x-axis. That's gotta be false, because a normal distribution curve then it would like, because a normal distribution, oh wait, that's normal density. I don't know if that's the same thing or not, but a normal density curve will shape. So you can't like, it just doesn't work unless normal density and normal distribution are different.
That's what I'm trying to figure out all of a sudden. I'm gonna go with it's false because I don't see anything else that.
Okay, I tried to look through too, but I didn't see anything that really said anything about that.
Because the only thing I found that said anything about it was the part
in section 3.4.
Yeah, the part where it says something about how it can't drop below the axis, but it's talking about so it says the density curve always lies on or above the horizontal axis. So, but that's the density curve.
Well, we have 2 shots.
Yeah.
So we'll find out.
I guess I'll just try this really fast and see what it says. Okay. I think that they're the same thing. According to Yale.
Okay. I'm currently searching the other question. Okay, yeah. All normal distributions are symmetric and have bell-shaped density curves. That answers question 5. A normal distribution curve is symmetric, so that's true.
True. Okay. Okay, so which
Okay,
of the
so question 6.
the z-score?
Represent the z-score.
I feel like I should know this. Didn't we learn about this in research and evaluation?
We talked about the bell curve. I think we briefly learned about the z-score, but mostly just the p-score. But it's pretty, I don't know. Whenever I read the introduction, it's pretty simple. But now we actually have to apply it.
Yeah.
I don't really know. I guess. Oh, okay. So whenever it comes for the rule for bell-shaped distributions, I don't know if that's kind of what it's referring to, but there's not a section in our book that talks about z-scores and shows a bell curve.
Yeah. Let me call this number is z-score. The z-score. So the z-score for a data value tells how many standard deviations away from the mean the observation lies. If the z-score is positive, then the observed value lies above the mean. A negative z-score implies that the value was below the mean.
I'm gonna assume it's B or C, possibly.
To make this big, she can see it.
Or could it possibly be none of these represents the z-score?
This, oh, hold on. The 68, 95, 99.7 rule states that 95% of the observed data values will be within 2 standard deviations of the mean.
That we learned about that in research and evaluation.
Yeah. How come it took me, oh, I thought that was a part of z-scores, and I was like, what does that have to do with this? But anyways, okay, so
Oh, okay. So if you go to, I don't know if this is going to work or not for this problem, but in section 3.2, it says converting a z-score to a probability, and then under that it has a bell curve. But if we don't know what the z-score is, then I don't know that we can convert it.
okay, so I looked it up on another website, and the definition of it, this is from Statistics How To, says simply put, a z-score is the number of standard deviations from the mean the data point is. But more technically, it's a measure of how many standard deviations below or above the population mean a raw score is. A z-score is also known as a standard score, and it can be placed on a normal distribution curve. The z-scores range from -3 standard deviations, which would fall to the far left of the normal distribution curve, up to 3+ standard deviations, which would fall to the far right of the normal distribution curve. In order to use a z-score, you need to know the mean and also the population standard deviation.
I think if it's gonna be something, I feel like it's gonna be one of those, but I'm thinking that it could just be that we don't have the information. Well, but then it said, I don't know, because then the next question is which of the following elements of the figure represents that the probability that the z-score will be greater than 1? So is it just that we don't have any of the information so we can't answer those problems? But I feel like they wouldn't give us 2 problems that we couldn't answer.
Yeah.
Do you know what I'm saying?
There's like a little video on this statistics how to about z-scores, and it's like showing the same chart basically. Do you want me to screen share it?
Maybe. I'm looking up z-score bell curve.
Because yeah, it's showing like the bell curve right here. I'm just gonna press play and see what it says. It's only like 5 minutes.
Okay.
I'll screen share it with you just because we might as well both watch it.
I just don't understand because I feel like technically couldn't A, B, and C all be couldn't they all be standard deviations within the z-score?
That's what I'm thinking. And if I remember, I'm pretty sure we learned about this in research and evaluation. And I kind of think it has more to do with like the uneven distribution rule, if I remember right.
Okay.
You see it?
Do you get where he's going with this?
Kind of, yes. I don't get where she came up with that 0.47 though.
Yeah.
Okay, so she's not helpful.
What'd you say?
I don't know. I just stopped it because I feel like it's not telling us what we need to know.
I just don't like. What's
I
the
get what it
difference
is.
in between? What?
I get what it is now. I just don't get how to find it.
Because I feel like all of those letters are part of it, right? And you have it almost makes it sound like it's the parent of all of these standard deviations. Like, here, kids, here you go. Here's a little place for you to play.
Yeah, kind of, huh? So is it that none of them represents the z-score?
I guess.
I don't get what A is saying though, like what A is pointing to. I also feel like that's part of the issue with this question. Like I don't get what it's.
Is it
Pointing
meaning
to.
like, is the z-score the blue or is it the white? Is that what it's referring to? But even still yet, then I don't know where C comes into play.
Should one of us guess A and one of us guess another one? And then that'll narrow it down a little bit.
Do you want me to?
Yeah, which one are you gonna guess?
What are you gonna guess?
I think one of us should definitely choose A because for some reason I feel like it's more probable that A is it.
Okay, so do you want me to do A?
Yeah, go for it. And I'll do B.
Okay. Okay, so 7, which of the following elements of the figure represents the probability that the z-score will be greater than 1?
I don't know.
I feel like that would be A. Because the probability that the z-score will be greater than 1, that's going to be the stuff.
Yeah, the thing that confuses me about that is
Well, but it's the
kind of
small
everything
numbers.
after 1. So is it B? Is B supposed to be pointing to that other red line?
I don't know.
Or is C?
Oh, C though. C maybe. I think C could be a guess.
Do you want to guess C and I'll guess another one?
Sure.
Okay. I'm going to guess B again.
According to the 68, 95, 99.7 rule, what percentage of the data from a bell-shaped distribution will be within 1 standard deviation of the mean? Write your answer as a percentage, such as 42, rather than a proportion, whatever, just a whole number.
So is it 95?
Is that the percents that video was showing?
Yeah.
But wasn't it different? Like,
It's
it was
68.
47. right?
If you look in the book, it's 68, I'm pretty sure.
Wait, in the book on what?
Do you want me to screen share with you again so I can show you what I'm looking at in the book? If we find you.
Sure. This thing, if you can see this.
Oh,
Do you see this? Oh, crap. Hang on. Do you see this? It has the area as 0.3 something something.
I will show you what I found. Where'd it go? Can you see that?
Yes.
Okay. So this right here, isn't that what our graph is showing us is 68?
So, but that doesn't, I guess I don't understand. Oh, within 1, so then it would be 0.68?
Yeah.
Okay, that makes sense.
Okay, because I'm pretty sure that's the same.
It says to put it, write your percentage like in a whole number, not. So we'll just put 68, like, okay.
Okay.
Okay, suppose that z-scores come from a standard normal standard deviation. Use the normal probability applet to answer this question. What proportion of the z-scores will be between -1 and 1?
What percentage? Well, it would be 68, wouldn't it? That's just what we answered, right?
Hey.
Okay, well, sounds like you're busy. I'm gonna be home around 9:30. All right.
Okay.
All right. I'll see you in a bit.
Okay, love you.
You too, bye.
Bye. Sorry, Emily.
No, that's okay.
Okay, so you're thinking 68 again?
Yeah, but I'm confused on why they would be the same answer. Because the thing that we found in the book, it says for any bell-shaped distribution, 68% of the data will lie within 1 standard deviation of the mean. 95% of the data will lie within 2.
I don't know if this is like what it's referring to or not, but the thing that I showed you at the beginning of the quiz, they said that you may use it or whatever. If you click on the little blue highlighted link thing, then this is what it shows you.
Yeah.
Can you see that?
Yeah, I clicked on that.
Good. The 0.3 thing? Okay.
Yeah, I clicked on it.
I'm not doing a very good job, but it says 0.3173. So do you think that would be is in between -1 and 1?
So it's in between. I'm just confused. Like, that makes sense. So it's referring to the space in between what we just answered, right? Like all that white space?
I guess so.
Because that would make sense that it would be it, because the other one, it's like 34% was what they showed in that video, right? From the center, it's 34% on each side.
I remember on the right hand side it said something about 47.
I'm gonna go with the 31 thing.
Okay, so it's 0.317.
0.317, so 32%.
But it says to give your answer as a decimal, accurate to 3 decimal places.
So it would be 0.317, okay. Suppose that z-scores come from a standard normal distribution. Use the normal probability applet to answer this question. What proportion of the z-scores will be between -2 and 2? So isn't that 95%?
But it says to use that normal probability applet thing again.
So then it would be
which was different.
0.954 or 959.
But it
'Cause
doesn't
I-
say between this time. Oh wait, yeah, it does. Ignore me.
Yeah, so would it be 0.955? Because in the book it shows, in that one graph I showed you, it has the decimals listed, so it's the decimal to 4 decimal places is
We could try it.
0.954. I feel like we're guessing hardcore, but okay.
If you look at, I don't know. There's a way I think that you can find it. So if you go to the section 3.4, it shows a graph where, well, another bell curve, and it's not quite, I don't know, it looks like 1.25 kind of. And, oh, it says 1.28. And then it gives you the area, it says is 0.90.
3.4.
No. Oh, yeah. 3.4, that's the section. Says
This is talking about percentiles, though.
stuff.
It says stuff.
Yeah. But it's still using that same thing called the normal probability applet. Because it says we can find the values of percentiles. So I guess would we be looking for the second percentile then? You can calculate it by corresponding to a specific, plugging the z-score into a z-score equation.
And the z-score equation, where's my notebook so I know what all these symbols are? No, don't do that. Oh man, I got frosting on my notebook. Not that that's important, but
For sure.
so it would be probability minus the mean over the standard deviation is your z-score, right? Is that little
Yeah.
HU combination thing, I can't remember what it's called, that's the mean, right?
The mean.
Yeah, and then
Yeah.
that
So
X,
we couldn't even find that if we wanted to.
which is probably what you have to do because that's
So should we go back with the 0.95 thing?
yeah.
Because we don't have enough information to really be able to calculate anything.
And that's what confuses me is, yeah, I think so. So I can look it up because we kind of can't tell. So let's see. I can find that decimal again for the, so the other decimal is 0.9973. So it would be 0.997 on question
Okay.
11.
Okay, so now we have the same question for number 11, except for between -3 and 3.
That's what I just answered was negative, or was question 11. So I think
So what did you put on question 10?
I put 0.955 and then I put 0.997 on question 11. I think we're supposed to be calculating them though, because
So
on question 12 it says look carefully at your answers to the last 3 questions. What do you observe? The values match the 68, 95, 99.7 rule. The z-score increases the area between negative z and z decreases, the probabilities double as you move from z1 to z2. And so our answer would be A, but that's because we just copied those decimals.
Yeah. Yeah. Well, and then my other question is, so for number 9, if we put the 95 and 97 on 10 and 11, then it would only make sense for -1 and 1 instead of doing the 0.317 for that to be the 68.
Yeah.
Is it just 0.68?
It's 0.6827.
So 3. But is that right? I don't feel like, I feel like we're missing something.
I'm pretty sure we're supposed to be calculating something, but I have no idea how to calculate it because I don't get how you get the mean still.
Yeah, I don't either.
There's another video on that super helpful website.
We could try it out.
Let's see how long it is. It's about 5 minutes. Do you want to give it a shot?
I don't know how else we're gonna figure this out. I mean,
I don't
I'll
get
keep
it.
scrolling through the book, but
Okay.
no. Just as a throwout of this chapter, it says the probability is us to use z-scores to calculate proportions, probabilities, and percentiles. So I don't know. So I guess like my thing is you have to apply one of those 3 things to our questions then. Because at first we were like, well, should we be using these percentiles? But if that's all it measures, then yeah.
Let's see what this says. I'm just curious to see if it ever brings up like a bell curve, so that we can see how you, because I get how to use the formula. I don't get how you apply it to the bell curve though, if that makes sense. Like how you draw the of that. So that's what makes me wonder,
I agree.
Oh.
Booyah. It talks about that in the book too, but we're not given a number.
What is this?
I don't know. What does that chart mean?
I'm pretty sure we need it because I'm pretty sure that it will tell us the answer.
So
Is it not?
that's how people are getting percents around here.
Yeah, isn't that what she is saying? Like, say that this was your 1. She just looked up what that 1 was and what percent it would be equal to. Isn't that what that just was?
Like in the previous video?
No, just barely. When she
Oh,
used,
you're saying like the 34.13.
yeah, that's like on our chart, that would be the 1, right? Isn't that what she just did with that? Everywhere from here to here. So from your 0 to your 1, your standard deviation of 1 would be 0.3413. Because all this is a standard deviation of 1. That's
So
one.
should we try that for question 9?
Should I look up that chart? Can we post this video? Are we cheating?
How?
Because I mean,
Where do
there
we
it
get
is.
that chart?
I will come back a little bit here and see what she calls it. Is it a binomial distribution table? Or is it a z-table? It's
I
a
don't
z-table.
know.
Yeah, I think it's a z-table.
Click the link in the description to view the z-table in this video. So I think it would be the z-table. Do we have that? I don't feel like I ever saw that. Yeah, we don't have that anywhere throughout our chapter.
So we probably shouldn't use it, huh? Because we're probably supposed to calculate it.
But I just don't understand how you could. So we have videos that we can watch to help us with the chapter too.
Yeah.
She would, or whoever does these videos, I wonder if they would go over that information in the video.
Yeah, we could watch it and see.
But there's like, I just pulled up one to see what it would be like. There's the part 1 is 9 minutes and 27 seconds.
How long do we think this video that I found? It's 2:52. Should we see what it says?
We could try, yeah. Oh, I don't know if we need to know that though, yet at least. So I think the video actually tells you what to do from
Okay.
BYU Idaho.
Yeah.
So I looked, it says, I just kind of fast forwarded to see what it would say. And if you go to like 1 minute and 52 seconds, it has us in the slide, the mean, it looks like equals the number of standard deviations.
The mean,
Something about that, but I don't have it at full screen.
I can't get my screen to go back to normal. Stop.
To go back to what?
I fixed it. I just couldn't get it to go off screen share.
There's, yeah, okay, so, and then there's also, so in the first video, it talks about the density curve, that 68, 95, 99.7 rule, and the z-score. And then in the there's a part 2 video, and it says converting z-score to probability, percentiles for normal distribution, and QQ plots. Okay, this is z-score represents the number of standard deviations. A value is a way of just putting in words what the equation is, but
I can't find my.
I don't know, Emily, that chart was pretty legit. I just am kind of getting frustrated because it seems like everything that we look at is they're showing us how to calculate it or figure it out if you're given a number. But we're
Yeah,
not given a number.
that's what I'm confused about is I don't get how to read it from the chart, like how to determine your mean.
Yeah.
See, and we're not given any numbers, so I think
That chart.
Where'd my quiz go? I think that these first few questions are the percentage things, because how do you calculate it without?
I think we're just gonna have to try it, and if it doesn't work out, then we'll have to go from
Then
there.
we'll
'Cause,
redo
I mean,
it,
what else are
yeah.
we supposed to do?
So let's just move on to 13 and we'll see what the other ones are. But it says the amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that the protein requirement will be normally distributed in the population of the United States. The protein requirement is given in terms of the number of grams of good quality protein that must be consumed each day per kilogram of body weight. The population mean protein requirement for adults is 0.65 grams protein. And the population standard deviation is 0.7 grams protein. What proportion of the population have a protein requirement that is less than 0.60 grams? I don't know.
Yeah, this is.
I don't even know what those kg number things are.
Kilograms?
Is that what they are? Is that what it's saying?
I
But the
think
exponent
so, because it
above
talks
it?
about consumed day per kilogram body weight. So I think D stands for day and the kg is kilogram, but still even with that information, I still am not sure how to go forward.
So if you look under 3.4 again, I'm pretty sure what we're trying to do is solve for x in the equation for the z-score. Because we know the standard deviation, right? I need to pull the
Yeah, it does say in the population, standard deviation is 0.07 grams.
So that would mean.
And so then it says a protein requirement that is less than 0.6 grams.
This might not be as hard as because the mean would be 0.65 and your standard deviation is 0.07. So your formula would look something like this, right? Oh, pink gel pen, bad choice. On the bottom. I can use black.
Is it? Yeah, okay, x equals 0.65 over 0.07.
Yeah, because 0.65 is the mean and 0.07 is the standard deviation. And so we would need to solve for x, right?
That seems right.
Okay.
So
by 0.07.
it's just multiply and divide type of situation.
Yeah. So isn't it 0.65 times 0.07 would give you x minus, what if I don't remember how to solve for x? 0.5.
Wait, what do you like with the multiplying and dividing?
I'm doing this all of a sudden and I don't remember how.
So you're gonna I need a piece of paper. You're going to take the x times the 0.65 and multiply it by itself, and it'll cancel it out on that side. And then it's going to move over to the side where the z is.
That's what you do.
And then you're going to divide the 0.65 away from that side. So it's going to wind up, I think, being 0.70 over 0.65. So if it is like that, then I got 1.0769 blah, blah, blah.
1.0769. Okay, give me just a second.
Okay.
You said you got 1.0, so it would be 1.08, right?
769.
Yeah.
Yeah.
What does it tell us to round it to? Or does it? Or should we? Did we do it right?
I don't know. It says give your answer as a decimal accurate to 3 decimal places. I assume round up, but I'm not sure.
So it would be 1.077.
Yes.
But does that make any sense? What proportion of
But
the
does that make any
population?
sense?
That does make sense though, kind of, because I was just saying, like, does that number make
Ooh.
because, but it does kind of, because it's less than 0.60 grams of protein. But we used 0.65, so do we need to use 0.60?
I don't know. That's what I was kind of confused about because I wasn't sure.
Ah. Why would they
So
do?
should I try, if you do, everything would be the same. So let me, so if you did everything the same, that would be 1.166666.
Does one of us want to put 1.077 and you put your answer that you just got?
I can. Yeah, you want me to do that? Okay.
Now, what proportion of the population have a protein requirement that is more than 0.60 grams? So maybe we're not doing this right at all.
Because one of them is less than and the other one is more than. So how are you supposed to judge? I don't understand how you're supposed to figure out which one's like, I just don't get it. Is this just like a lack of us preparing well, or is this like it's just not very clear?
It's probably a little bit of both. Like, I feel like the book isn't corresponding very well with the lesson here. Because this formula works, it doesn't tell us the z-score though.
Yeah.
So technically we haven't solved for x because we didn't technically solve for z either. I just realized.
It doesn't tell us that formula?
It tells us the formula, but the information doesn't tell us the z-score. It just tells us the mean and the standard deviation.
I'm kind of, I don't know.
But we could, with the 0.60, we could calculate the z-score because that 0.60 would technically be your observation. So then it would be 0.60 minus 0.65 divided by 0.07, right?
But my question is, so you could do that, but what's the difference like in our calculation process for less than 0.6 and more than?
And that's what I don't get. But do we need to have the z-score in order to figure it out? because I don't see anything about, that's the closest that I can find in 3.4 is to what we're trying to figure out here. Like, I don't find anything close to it at all.
So, do you think that this is something like use the equations that they've given us? Like they have in there P times kilogram. Well, I guess the P I'm assuming is protein. Protein times kilograms times days. Do you see that?
Mm.
Oh, wait. And the population standard deviation is 0.07 grams. So they gave us the standard deviation. That's what they gave us.
And they gave
So, and the requirement.
population mean. So
Proportion.
if we drew it out, it would, because 0.65 would be the center, right? I have no idea how to do this. Do we both just want to watch the videos and like each take a video and then come back in a few minutes and try to figure it out? Because those have to be where it shows you how to.
I think I don't want to do that, but I think that we're gonna have to do something because I don't know how to do the remainder of these questions, and they're all. I think that part 2 is gonna go over all of this information because this is all about proportions and probability and percentiles. If you go down and look at the remaining questions.
Okay, so we can just stay on air and mute our microphone.
So if
Each take a video and just watch it. How long is that video though?
well, if okay, so the reason why I think it's probably all going to be in part 2 is because it says what it goes over is converting z-score to probability, percentiles for normal distribution, and QQ plots. So I don't
Okay.
think like at this point in the quiz that we're going to benefit answer wise from part 1. Part 2, the video
Does one of us want to watch
is
anyways though, so we can answer the earlier questions, right?
we could. Both of them are about 9.5 minutes at least. Like this one, the part 2 is 9 minutes and 49 seconds.
Yeah, let's just do that. Which video do you want to take? And I'll take the other one. That way we can at least answer the questions, right? It might take us 10 minutes longer to watch the video, but
Okay, I'll watch part 2. I have
Okay.
it pulled up right now.
okay, I'm just gonna shut my mic off so you don't have to hear it.
I found a part in this video that shows us how to do some of the answers. Your mic's not on.
Sorry. I was
You're
chatting.
totally fine. I was like, I don't know if she's still watching her video or if she
Could you see my mouth moving?
heard me. Yeah, I was like, what the heck? Either she's talking to the computer or she's meaning to talk to me. So
Yeah.
we can keep watching. I just, I found a part in here that goes with those questions that we were just trying to do. So I'm just going to show you this screen.
Okay,
See if it
lost you.
works. Whoa. Okay, can you see that okay? I don't know if I'm getting everything.
Z equals, it keeps flashing. Z equals 240 minus 266 divided by 16 equals 1 point. So we are supposed to find the z-score?
Yeah, that's what it keeps on. Oh crap. Oops. That's what it keeps on like telling me. But the thing is even like earlier in the video, it showed a chart and it had like, it was so simple. It had the mean and the standard deviation already given. So I don't know if in like those questions that we were just working on, is there something that we're missing? Like, is the mean supposed to be the 0.60 because they gave us the standard deviation? Do you get what
They
I'm
give
saying?
us the mean too, and the mean is the 0.65. The observation is the 0.60. So you can find the z-score, you can find z with that.
Hang on just a second. I have the door locked on my husband.
Well, it's frustrating for me because and I have used that game. I used that time. I called Jordan from months ago. I have 2 cells today. She didn't try to do
Okay, sorry, Emily.
No, you're totally fine.
Okay.
So this is what it should look like, right? The formula. Down there.
Yeah, I think those 3 numbers are key. It's just hard to know which spot they go in, but I think that's right.
But it says 0.65 is the mean. It says it in the question. Somehow.
Then let's try it.
I don't have my quiz anymore. Fetch.
What?
Where'd it go? Yeah, the population mean protein requirement for adults is 0.65 and the population standard deviation is 0.07. So the less than 0.60 would have to be your observation, right? Because you're observing what is less than that.
Yes. So here we go. Okay, so we're going to say 0.60 minus 0.65 because the 0.65 is the mean, divided by 0.70, that's negative 0.07.
Right, so that would be our z-score. And so in those videos, did it tell you what you do with the z-score? Because from the z-score, we have to figure out.
So it said that you're supposed to find the area. Oh, crud. Fast. You're supposed to find the area underneath the applet, which is what was given to us. Emily. They just moved stuff in the applet. Does this thing? Oh my gosh. Do you realize what this applet can do? It's not just a picture. You can move the lines.
Oh, really? That is so
This
cool.
whole time.
That
This whole time.
we're like, what is this?
Gosh, there should be a tutorial for these kind of things.
So we can move this applet to our exact z-score.
Yes.
Hold up. Okay.
Now we're finally in business.
That's why you do your preparation homework. Okay.
So if that's the case, whenever I go to 0.070, I can't get it quite on the 1.
You're supposed to be able to type it in there, but I can't quite get mine to stay. Oh, I did.
Oh. Even smarter. I didn't know you could type it in there.
I think you have to type it in the positive one first or it won't stay. Mine wouldn't work if I didn't do it in the positive one first.
That makes sense. Okay.
So then is the area
So
0.4752, is that something significant now? Because it changed?
okay, so the area, yeah, the point, well, for your area, do you have 0.9434?
No, I have 0.4752.
How can this be?
What number did you type in?
I typed in 0.071.
You got 0.071 because I got 0.714.
You got what?
I got 0.714.
So whenever I did 0.65 minus 0.60, I get 0.05, and then I divided that by 0.70, and I get 0.071.
What? I'm using my cell phone, so this could easily be me.
Well, no, I'm using my cell phone too. So you did 0.65, right? Minus 0.60?
You're supposed to, I think you're supposed to do 0.60 minus 0.65. Because in the
0.60.
formula, it's the observation minus the mean.
So even if that's the case, it's still the same number, but negative.
See, and this is what I get.
Why?
I get this.
Okay, are you doing point? Are you doing point? Okay, I'm gonna do this. 6.
So
Oh, whoops. That was so bad.
0.60 minus 0.65. Then I get negative 0.05.
Okay, I feel like, okay, I get the same thing.
So
6,
where?
5. So same thing. Wait, are you getting 0.05 negative?
That's exactly what I get. And then I divide it by 0.07.
Oh, 0.07?
Yeah.
Okay, I was dividing it by 0.70. And I do remember that it is 0.07. So you are right.
Okay. Okay. So then what do we do with the 0.4752 now? Like, does it say what that area means anywhere in that video?
I think that's, oh, you can do other things with the applet, but I don't think it means anything to us right now.
The area doesn't?
I think, what?
The area doesn't?
So I think that, what proportion of the population? Maybe I should keep watching the video.
Okay, I'll just watch the other one until you have it.
Okay.
Because I think it's going to help us with the earlier question.
Okay. Okay, so I'm kind of confused.
Yeah.
So I watched the rest of the video, but it starts going into the QQ plot. And so, like, that's all it says about probability. So I'm kind of confused because even like, I'll show you this title or this, I don't know, the slide again. But even like on the top of the slide, it says steps to finding area or probability under normal curve. But then you saw, I mean, we went through the thing and nothing, it gave, whenever it was asked find the area under the standard normal curve using the applet, that's where that like number that we got, whatever it is right now, like the 0.47, that number, that's what they put for that, but that's not what we're looking for. And then on the other question, it was basically just to find the z-score. So I'm like, okay, but you're not really telling me what I'm supposed to be doing now.
With the numbers.
I'm not really sure. I guess the probability under the normal curve, that's how it's phrased. So maybe that is the probability, is the 0.47.
That's what I'm thinking, because like technically, if you think about it, like when you adjust those lines, you're adjusting the highlighted area of the bell curve. And so that 0.47 would be whatever is left over. Right?
Right. So
And technically, like percentage-wise, that would make sense.
Given the information that we have, that is the most educated answer.
Okay. I'm going to keep watching this so that I can see if it helps us at all with those.
I'll see if I can figure the next couple questions out with this information.
Okay. So I don't know that that video taught us anything.
So I have, and he took business statistics. So I'm asking him how to do stuff, and he knows how to do stuff on this applet. So he's kind of teaching me what to do. So I think we have another resource now besides Google.
Okay, good.
You have so much faith in me.
So
Okay, now minus that.
okay.
Now, how many times does this let you do it?
Twice.
Have you already done it once?
Nope. So you think that's what the answer is?
Let me get through there.
So Emily, I don't know what to do on, I think it's, I don't know which number it is. Hang on for a second. I don't know what to do on number 14.
Yours is just completely different than ours. Like completely different.
Why?
We had different applets that we could just plug in the numbers and do it all for us. We had an Excel saying.
So Jacob is saying that they had all kinds of other applets to use, so all they had to do was plug in the numbers. So, no, I mean, that's the only resource we have, right? That one applet. There's not anything else, right? I'm not missing anything.
No.
Oh, wait a minute. Do you know how to calculate the z-score?
We kind of do.
Okay, you need to calculate the z-score for this. So tell me what that is.
For 0.60?
Mm-hmm. I don't remember how to do it. 'Cause if I had all my formulas, I could tell you.
Right.
Do you have the formula written down somewhere?
Yeah, it's right here. Value minus mean equals standard deviation.
Okay, that's what you mean.
So 0.60 minus 0.65 divided by 0.70.
How do you know it's 0.65?
That's the mean. It was already given to us.
Oh, okay.
So that's the answer
Okay,
we get.
so this is what you do. You take that number, you shade to the left, plug that number in. Point
Give a star. But I guess we don't.
negative 0.32857. Okay, so that's that probability. So write that down somewhere. Okay.
Okay.
Well, then we're going to need to calculate the other z-score. So.
Okay.
Okay, write that down. Score for the next one. Okay, so that's a z-score for the next one.
Mm-hmm.
It's negative 0.07142. That's the probability for that. And then you minus those. Make sure to minus
The
that
big
one.
one.
That one.
Okay.
And hopefully that's your answer. Is there a way to check it?
Well, we just have to turn it in and then find out.
Okay, hopefully that's your answer. I think that might be it. I'm not 100% sure. Like I said, we had a thing that did it for us. So.
3 decimal places. Okay, I think for this. Okay, I think that's how you do that. What if you shaded that side too? Would that change the answer? It does change the answer.
I don't know. Yeah, the contact time. I remember, like I said, we had stuff that we just plugged it down.
Okay, thanks. Okay, so I think maybe, I don't know for sure, but he kind of tried to show me how to do some of these problems towards the bottom. So I can show you what we did and see what you think.
Okay. I'm pretty sure that those questions up towards the top are just as simple as moving the normal probability applet
Okay.
to each of the standard deviations. That's what I got from that first video, but I'm not 100% sure that's right, but I think that's what you do.
We're just at this point, like we're just gonna have to try and see what happens. Okay, so for question 13, we did that one together, right?
Mm-hmm.
So then for 14, I'm not sure how to do that because in the video it said less than 2, and I don't know if there's a difference between more than. I mean, there's got to be something different, but I don't know what it is. Like, is it 1 minus the 0.475?
What question are you on again? 14?
Yeah.
What proportion have a protein requirement that is more than?
And it's the same question as 13, except for more than instead of less than.
So there was this thing in the video that I watched. I wonder if I can show it to you and see what you think about it. Where would it be? Okay, so okay. So this slide, this mean, I can just tell you what he says right here.
Mean plus.
Right. Okay. So does that kind of help us answer that? Did it ever screen share with you?
Yeah, it's screen shared.
Okay. Because I need to read it again, but I kind of think that might be able, if we think about it enough, I think that might help us answer it.
I'm not gonna lie, I'm kind of considering just subtracting it from 1, seeing if that's right. If not, okay, but
Because six point six, if the mean, let's see, let's think about this. So if the mean is 0.65 and our standard deviation is 0.07, then 0.65 minus 0.07, that would be 0.58 would be 1 standard deviation away from the mean. If you like drew that out.
okay.
So 0.60 is just barely over 1 standard deviation from the mean, right?
Yes. If all that information is correct.
Yeah, going off of what we have. So 0.58, 0.58, and then 0.60 would fall roughly right there. So the question, what proportion of the population have a protein requirement that is more than 0.60 grams? So let's see. .72. I have no idea if this is right, but okay. And then I wish you could type in below this thing. So that'd be 0.65, 1 would be 0.58, and 0.60 would be like right there next to it. So almost 1. So
Do you want me to just submit what I have and see what I get?
yeah, because the way I'm thinking about this, I'm getting like 0.72 if you use that little like formula he gave you about finding the higher and lower value. But that's like basically what the standard deviation is. And so the 0.714 makes more sense because you're using like an exact number. And our 0.714 is the z-score.
So,
So,
but
it might be as simple as if
Wait.
0.65 is your mean.
Didn't we put in, so for question for question 13, we put all that information into the applet, right?
Mm-hmm.
So you're saying that the z-score is
So your
0.714?
Yeah, so your proportion that would be above the 0.60 would be, wouldn't it be the 95% of people? Because
Hey,
it's
I just had a thought.
okay, yeah, have a thought.
Sorry, I was not listening, I'll be honest,
No,
to that
totally.
part.
I'm just making stuff.
staring at this applet thinking, so you're breaking up.
Am I?
Okay, now you're normal. Okay. So
Yeah.
if the area of the applet is saying that it's 0.475, right? That's where we got our number from for question 13. Then would we, I guess if that's the area, so I'm going to put that back into the applet, then should we just find the area of the other two sides?
I think we're saying the same thing,
Okay.
kind of.
Honestly, is it really as simple as 1 minus 0.475?
I kind of think so. The thing that's really hard is that one formula is like the closest thing that we were given, and 0.60 is almost one standard deviation, like it's just above one standard deviation. So I don't get how to calculate it. Because technically, if your standard deviation is 0.07 and your mean is 0.65, your first standard deviation would be at 0.58. You know, so what do you do with that 0.60? Because we don't know how to calculate that. Like, it doesn't say anything about calculating in between.
The thing is, though, if we're it's the same question except for more than. So if we were going to use that standard deviation, then I feel like we would have already done so. In the case of numbers.
Yeah, and that's a good point. I
feel like it can't be that complicated because it's
I think we just do the 1 minus. I think we just do the 1 minus 0.4752. Because that would be the more than, and that's going to give us close to what I calculated, I think.
Yeah, it's 0.525.
Yeah.
Okay, so for the remaining questions, I can like show you what I did and see what you think. So question 15 is exactly like question 13. And it's kind of weird, but whenever I plugged in the numbers, you can double check me. But whenever I plugged in the numbers, it came out to be the exact same. The 0.714, I think, is what we had earlier. And so I have the exact same answer on question 15 as I do for question 13.
That's weird.
I was like, wait, Abby, am I doing this right?
X5. Yeah, because that's what I'm going to get to when I do this. It's just positive. It's a negative. Did you put in?
And so even though like it doesn't, I don't think that has an impact on this stuff either, the positive or negative, because it still is the same on both sides whenever you do the applet.
Yeah.
So I have the same answer on that, so 0.475. Okay, for question 16. This is the one that Jacob helped me with because I don't know what we were supposed to do. So I'm going to show you my screen and hopefully this will make sense. Okay. Probably be easier if I did this on my computer instead of on my iPad, but okay. So what I did was you take away one of the areas.
Mm-hmm.
Okay, so then I do 0.60 and oh crap, that's not right. Maybe I'm supposed to put it over here. Still not the right answer, Abigail. 0.60 and 0.60. 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 0.60 and hang on. I'm trying to remember how he showed me how to do this. Okay, hang on. Basically, I don't remember how he showed me, so I'm gonna have to ask him again, but I got these two different numbers that were supposed to be the, oh, I remember what I did. You use these numbers to find the z-score. Is that right? Hang on, he's in the bathroom, but I'm gonna see if he's done. Can you open the other one? We need help. Okay, I'm back.
Okay.
So what you have to do is you have to find the z-score for each of those numbers. So for the 0.60, and then for the 0.70. So I don't remember what the z-score was. So now I'm gonna have to redo that. But
So it's 1.077. And
okay.
so for the 0.60, it's a negative. And for the 0.70, it's a positive.
This is 1.077 is the z-score.
Mm-hmm. Yeah, I have it written down in my notebook.
Okay, we actually have the z-score from these.
Wait,
Right?
no, it's not that. The z-score is the negative 7 or 0.714. So for 0.60, it's negative 0.714, and for 0.70, it's positive 0.714.
Okay, I don't know. I'm kind of irritated because I'm not getting the same thing that we did
Before. If he showed you how to find something different, then
Yeah.
that's
I don't know. I'm so mad. Okay, so
0.60, I did 0.60 minus 0.65 divided by 0.07. But I don't know if I'm right. Like if he showed you something different, then he's probably right.
well, I don't remember how we did that. That could have just been my fault. But those are the z-scores that we had earlier, so maybe we should just go off of this. We can try it. Okay, so what you do, I'll show you my screen now. Basically, what you do, though, in short, is you plug in that number, so the 0.714. I just don't think that makes sense, though. Okay, anyway, you plug that in, and then it tells you you only shade the left side of the bell curve, and it gives you the area, but then you're supposed to subtract those to get the answer. So the problem is that both of those are going to have the same, it's going to be 0 if we subtract them. Do you see what I'm saying?
Yeah.
So that's how you're supposed to do it. You're supposed to put in the z-score for each of those numbers and then it does its thing. But
Maybe I'm missing part of the z-score formula. But I don't think I am.
so I don't know how the heck, I really don't know how the heck I got it the first time, but the answers that I got for them, the areas in the end was 0.3711, and 0.4717, but that's not the area that we're getting, and they were two different ones. But if you think about it, the z-scores were the same to begin with, so is it just 0?
Yeah, let me do it on the dill and I'll see what so I type
I'm
point-
kind of mad now because I don't know what.
left. That's not left. So the area you get if you shade to the left of them is 0.7624. Remember
Yeah,
that?
only to the left.
And then subtract the smaller area from the larger area. So is all that saying, because on your bell curve there is a smaller area from the larger area, like the part where it goes or
Maybe.
narrower is smaller. So if you unhighlight the large area, that's 0.2376. So I unhighlighted the middle area, and then the other one is 0.5248. So that gives you,
Well, yeah. 0.2872.
yep.
But even if you change this, if we have the same z-score, then it's going to be 0 no matter what you do, no matter how you get this number. Unless our z-scores are different, which right now we don't have them as being different.
But you don't do anything with the z-score after you subtract those two areas, do you?
So
Because remember that to find the area between
the
two
thing
values,
is we could try to put in this number, the 0.2872, but what he was explaining to me is there's supposed to be one for 0.60 and one for 0.70, like the same process, two individual ones, and then what your numbers are for each other are supposed to be subtracted from each other. You would find the between, because it says between 0.60 and 0.70. Do you get what I'm saying?
yeah.
But
Okay,
that's why I'm saying,
is
like,
this though what that one video was trying to show us?
I don't know.
No, it wasn't. It was showing
See,
us.
because it says, remember that to find area between two values, shade to the left of each z-score you calculate, then subtract the smaller area from the larger area
So that's what we did.
of the z-score
And then make
total.
sure your answer
there
is
should be,
positive. Our answer is
but there should be two
positive.
areas, like two totals. So like at first,
But that does give us two areas because we had a smaller and a larger area. The 0.52 is larger.
it's not in the same bell curve. It's supposed to be the two different totals.
Oh,
Do you see what I'm saying?
why are we getting the same z-score? Oh my goodness.
So then it has to be 0. I don't know how else.
Because, yeah, and I looked it up in the book again, and I even did the problem with the z-score in the book, and we're doing the z-score right. Like, I followed along with the book, that baseball example that it gives, and we're doing the formula right. Like, I was getting the same answer. So
I don't know how the heck I got the number that I got the first time, but do you want me to leave that number in the crazy wild idea that it may possibly be right, however I did it, and then
this
you
is
put
what
0?
I'm thinking we do with the quiz. I'm thinking that we give you all of my answers from up top where I changed them, and we have you do all of these answers and submit one of your submissions. And then we won't submit any of mine and we'll see what we get. And then next time, if we miss a lot, we can submit one of my submissions rather than both submitting at the same time. If that makes sense.
So do you want to submit first or do you want me to submit first?
I think that you should because you have most of these answers. Did you guys
Okay.
get 18 or did you just?
I can tell you how to do 17 and 18 really quick.
Okay.
Easy.
Okay.
So all I did, hopefully this is right. This is what I understood from the video and this is what Jacob said. So I'm, you know, in the witness of two. I'm hoping it's right. So you go back over to the applet and in the area section, you just punch in 0.35 and you have the right and left sides shaded.
And it gives you
And
point or 5.4.
Grid, where'd it go? And then it gives you
0.935.
Yeah, it does.
Okay.
And then for the 80th, it's the same thing. So then you just put in 0.80.
So it's 0.253.
Mm-hmm.
Okay, so I'll hurry and read you all of my answers from the other ones just so we can be sure that we're like on the same page. So on question 3, I put 1, and then 4.
Okay. So you want me to change my answers to what you have?
Yeah, and so because I recalculated the first ones that we did according to what that video said, so I don't know if they're wrong or right, but then that way we're not both wasting a quiz. We're just wasting one quiz.
Okay, we'll just.
Yeah. So let's see. And then
number 4, I have false.
False. Number 5 is true. On 6, I ended up putting A.
Okay.
Because I think that's what makes sense. And then
that's what I have.
And then on 7, I put B, and I'm pretty sure 7 is right.
Okay, I'll change mine.
And then on 8, I put 68. And then on 9, I put 0.317.
I have 0.683.
Yeah, I changed those because I'm pretty sure
because that's whenever
I was moving the probability applet. And so that's what I did.
So you don't think it's the quartile things?
I think it correlates to them, but I think that you what was I going to say? I totally just lost my train of thought.
It's all good.
I think it's just as simple as
because that's what we have for question 10 and 11. So did you change those too?
Yeah, so it's 0.317 and then 0.046 on question 10.
Do you want me to change those then? I mean, we can get those numbers back really easy.
Yeah, I think that we should change those. And then question 11.
So remind me what you have for question 9.
9 is 0.317.
Okay, and then 10, what is that?
0.046.
Okay, and 11?
0.001.
Okay.
And then I still said on question 12 that the values match the 68, 95, 99.7 rule.
Okay. And then 13.475.
Mm-hmm. Then I have 0.52 on 14.
And 0.475 on 14, or I mean on 15.
Mm-hmm.
And then oh crap, my computer's not today. Hang on, 0.101 on 16. Oh wait, don't do that one. That was the one that we had discrepancy about. So I'll just write down the number just in case, and I'll change it to whatever we got. Hang on just a second. My gosh. Okay. Okay, what was the answer that we decided to do for 16?
I put 0.101.
You?
Yeah, because that's what you told me.
Okay. Let me go back. Oh, because we were trying to decide if it's 0 or okay. Should we do 0? Do you want to? Okay, do you want to leave 0 or do you want to do the 0.101? Which is the random number that I got the first time.
Do you want to try 0 first? Because I feel like it's maybe more probable
Yeah,
that it's considering that.
Let's try 0 first.
Okay.
Okay, and then on 17, we have 0.935 and 18.253.
Yep.
Okay, do you want me to submit or are you going to?
Maybe you should this time. Let's see. Yeah. And then I'll submit
Okay,
next time.
I will this time.
I'm gonna go to the bathroom really fast. I'll be right back.
Okay.
We had tools to help us do it, so. And we had all the formulas. That's not an easy, that easy to class if they don't give you the material to figure it out. I'm sorry, I don't know how to help you. If you had the formulas, if I had my notes from my stuff, then I might potentially help you. But if you pull up my old stuff, I don't know if I can still have access to my old stuff, if I need to do that.
Okay.
You're gone, then you work from home. Is there a way to like I guess, and that fits on the
I'm sure it's either that's right. App Store. Okay, so I got a 50%. Or
Oh.
2.5 hours, basically, of doing this.
Fuck.
Yeah.
And it doesn't tell us which ones are wrong, huh?
Hang on. Yes.
Did you get the one right that I told you about?
I'm not sure. Okay.
It doesn't.
I didn't get what?
You go ahead.
We got nothing from 13 to 18 right. So apparently I'm not doing any of those right. So none of those are right. And then we missed 10 and 11.
We missed what?
11.
11.
We missed all 9, 10, and 11.
Oh my head. Ah.
And 6. So actually, what I might do is just take pictures and send them to you.
Okay.
I don't feel like it should be this difficult. Because we've spent a ton of time on this.
And we missed 7.
I literally got a 50%. Oh wait, are you asking about question 7?
Yeah.
No, we got that one right somehow. 7 and 8 are right.
Okay, because I was like, if we miss 7, I don't know anything about this, because that is the easiest question.
Yeah, so nothing. And I don't know how to do this, and I'm kind of fed up at this point.
We got 8 right though, right?
No, wait, hang on. Yes. 7 and 8 we got right. 9 wrong. I'm sending you all the pictures right now.
Okay, so I'm saying that on 9, 10, and 11, when I submit my quiz, we just change them back to like the 0.68 answers.
Yeah, that's what I'm thinking.
Okay, I'll do that really fast because I don't
know what else it would be.
Yeah. I seriously do not know how you're supposed to get anything from the book on this.
I know.
Maybe this is why
Well, apparently it's a lot easier in business statistics because they give you applets and you can use Excel instead of SPSS.
Well, dang it.
What?
So dang it.
So those are hopefully about to go through to you. Should I just go ahead and pull up another quiz?
Yeah, I'll submit this time so you don't waste your quiz submission, your last one.
Are you just going to try changing the 9, 10, and 11?
I'm going to try changing all of them, but for right now, I'm going to change 9, 10, and 11 for sure.
Emily, what should we do about 13 through 18?
9 and 7.
I mean, I have no idea. Seriously,
We got question number 12 right? I don't know why I'm not getting messages. Hello.
Yeah, it's your stuff.
That's my stuff. For Netflix.
Oh, for Netflix.
So I think I may have had a small breakthrough actually, but this could be
Really?
wrong. But you know how I was talking about how the standard, when we subtract 0.65 from 0.07, and that gives us a standard deviation of 0.58 for the first standard deviation? If you type 0.60 into the probability applet, that gives you an area of hold on. I just messed it up.
You're fine. Where's my freaking email?
That gives you an area of 0.756, or excuse me, 0.726. Which kind of makes sense because you're just above a standard deviation of 1. Except the stupid thing about this normal probability applet is you should be able to type in your individual mean so that it gives you it, because that's all we would have to do if we could put our mean in. Like, I don't know if this is going to be right because it doesn't give us the mean. So that number I said was right. But it's like, if we're doing what I'm saying, and our standard deviation of 1 would be at 0.58, then we would be at somewhere around 1.05. No, excuse me, 1.046 for our. So that would give us around 85. It would be 0.852 for the proportion of less than.
If you think that you found something that could be right, I say that we try it because we don't have anything to lose.
I just don't know how to get the exact number. Hold on just a second.
You're fine. Good.
Okay, sorry. I have no idea. I get what it's asking and I get how to do it, but I don't get how to figure it out because you can't put our mean in to figure out or to get it to go to scale on this stupid dill so that the standard deviation is, but it's like, it's roughly around 85%. Or did you figure something out?
I'm gonna send you something, okay?
Okay. On,
yeah. Well, okay, hang on a second.
okay, I got it. And I responded.
Seriously?
Uh-huh.
You never have?
Uh-uh.
In instances like these, it can be very helpful. I'm sending you some other stuff.
Okay. I just want to know if this is as hard for everyone else as it's as hard for us.
I agree. So what I'm saying is that maybe with some of that help, we can figure out how to find the answer.
Yes. I agree. Um,
So for the the 8, 9, oh wait, that's not what I meant. For the 9, 10, and 11, we'll just put the normal scores, so like the 0.683,
okay.
because that's what we were gonna do the first time, but then we.
Okay.
And then 0.955, and then the other one was 0.997.
Mm-hmm. So does question 13 then end up being roughly around 85% or 0.85?
Let me look into that. Okay. Okay, so for 13, you were thinking 0.8 something?
Yeah. No.
No. Okay, so maybe opposite? I'm not sure.
If you oh. Code of numbers.
Getting frustrated. I can't, I'm trying to find more information, but it's not working out.
Yeah.
Okay. So I found some more information that could be
Okay.
helpful, but I'm kind of actually confused.
Okay.
I think we were getting, I don't know, it was backwards, which I don't really know how that could be, except for the fact that we just don't know what we're doing.
Have a protein requirement that is more than so it was backwards. So for question 15, you got 0.762.
Yes. Okay, I have a scientific calculator, so I'm actually gonna double check some of this stuff because, you know. I think we must be, the only thing I can think of is that we're doing something wrong with the probability applet.
Yeah.
But maybe we're not. Oh. No, I don't know. What?
Tell us more about this in like the homework section. Did you do the homework for it yet?
I have not. Maybe it does. I don't really feel like we were taught how to use the applet, but yet we're supposed to use the applet for like all these questions.
I read through it in the book and I don't get it.
So I have no idea. I just flat out.
Can I double check my answers with your answers and then I'll submit my quiz and see where we are?
Okay.
Okay. So for let's see. Question 6, I put none of these represent the z-score. What did you put?
Wait, number 6? Okay, so I did A, and that was wrong. That was not right. So I would try that.
Okay.
And then
Not finding anything else on that one?
what? I didn't really look specifically though.
Okay.
But I think we'll be okay. Since this
Okay.
is
Okay,
so question
I have B for question 7.
8 we had is still the right answer was 68 like we had before.
Okay. And then question 9, I have 0.683.
Yes.
And then question 10, I have 0.955.
Yes.
Question 11, I have 0.997.
Yes.
And then question 12, I have the values match the 68, 95, 99.7 rule.
Mm-hmm. Yeah, right.
Question 13, I have 0.238.
Yes.
Question 14, I have 0.762.
I don't know what 14 is, but I think, I'm not sure. I think it could be that, but that's what those are the answers that I have for 15. Oh, wait.
I have that for both 14 and 15.
Yes, you should. You're right. I was double checking.
Okay, so for question 16,
Okay.
0.525.
Yes.
For question 17, I have 0.623.
Yes.
And for question 18, I have 0.709.
Yes.
Okay, I'm going to submit it.
Okay.
Question 6, we're still wrong.
Dang. Okay, let me.
We got the rest of them right.
Question 6 is the only one.
Yeah. I'm going to stop the
Okay.
podcast right now because it's probably going to take forever to upload to YouTube. So
Yeah, that sounds good.